Oh, well, let's do this. Prove the identity. The identity is here. So we have 1 plus sine theta divided by 1 minus sine theta. What we are going to do, we are going to get the conjugate of the denominator. So we shall get the conjugate of 1 minus sine theta. 1 minus sine theta, its conjugate is 1 plus sine theta. The conjugate can be got just by changing the sign in the middle there. Instead of having a minus, you have a plus. So we are going to get that conjugate and we multiply it up and down. If I multiply the conjugate up and down, it means that I have not changed the equation. It remains the way it is, because the one which I have multiplied can cancel anytime. So we are going to have 1 plus that one is this one is multiplying up and down by the conjugate. So when I open the brackets, because what I have, maybe let me have this step also, multiply out, but you can see that up there as the numerator you have 2 brackets which are the same. So I can write it as 1 plus sine theta squared, and down here I have this one as a difference of 2 squares, 1 minus sine theta with this one as a minus and this one as a plus. So I have this one as 1 squared, which is the same as 1 minus sine theta squared. That is sine theta squared. And now I shall open the brackets of the numerator, and I apply for the denominator. I'm going to apply the Pythagoras theorem. By using Pythagoras theorem, we can prove that cos squared theta plus sine squared theta is equal to 1, implying that whenever I have like the 1 minus sine squared theta which I have here, take this one that side, and we shall remain with the cos squared theta. So we shall have here that when I open the brackets of the upper thing, I'm going to have 1 plus this is twice the product of the 2. You are multiplied, it is 1 and then sine theta. So the product of 1 and sine theta is sine theta, then plus sine theta squared, and divided by, I'm going to put here cos squared theta. Now this one is the same as I'm going to divide each term. I shall divide each term by cos squared. So 1 divided by cos squared theta, I get sec squared theta. 2 sine theta, this is 2 sine theta divided by cos squared theta. I can get this one as for the sine, there is 1 cos here, because this one is the same as 2 sine theta divided by cos theta cos theta. So for the sine and the cos, that one is a tangent, and then 2, the one over the cosine which remains out down here shall get that one will get us a sec. So this is 2 tan theta sec theta, then plus sine squared theta divided by cos squared theta, I get tan squared theta. And this one is the same as having sec theta plus tangent of theta, everything squared. So, and this one is exactly what we have on the right hand side. If you have ever had any basics of trigonometry, I think you can follow this. For those who are just starting, we shall learn as we move on. But for now, I sign out. Well, this one is another problem where they want us to prove an identity. As I told you in the last video, we must either start from the right and prove what is on the left, or we start from the left and get what is on the right. I prefer starting from the left, so we are going to have that what is on the left is equal to what is on the right. What is on the left is 1 minus sine theta plus cosine of theta divided by 1 minus sine theta. We are going to employ the same method of getting the conjugate of the denominator and multiplying it up and down. This is what we do. This is what we have after multiplying up and down by the conjugate of the denominator. The conjugate of the denominator is 1 plus sine theta. You can get that by changing this sign here. What was minus becoming a plus. We now have to multiply. Let us open the brackets. We shall multiply this whole expression by 1 and also multiply this whole expression by sine theta. So 1 times everything here, we have 1 minus sine theta plus cosine of theta. That is upon multiplying 1 by everything. Then multiply sine by everything. 1 times sine, that will get us sine theta. Then sine theta times sine theta, but we have a negative there. That one is sine theta squared. Then the last one is cos theta times sine theta, which is cosine of theta times sine of theta. We are dividing this one by, in most cases, after getting a conjugate, you remain with something which resembles which is actually a difference of two squares. So I have 1 squared, which is the same as 1 minus sine theta squared. And from there, you see that this one, the sine theta will cancel, because there is this sine theta and there is that sine theta. One is positive, one is negative, so they can cancel. So we shall have this one. I'm going to put together this one and this sine squared. So let me first write cosine of theta. I have cos of theta. Then I have this. Okay, I have cos theta sine theta. This is plus cosine of theta sine theta. Then plus, let me put this in bracket, 1 minus sine squared theta. That's what I have as the numerator. And this one is divided by using from Pythagoras theorem, we got sine squared theta plus cos squared theta equal to 1. This one means that 1 minus sine squared theta is the same as cos squared theta. So down here, instead of sine squared theta, I have cosine squared theta. And again, 1 minus sine squared theta, which is up there, can be, it is still a cos. So I can write this one as cos theta plus cos theta sine theta plus cos squared theta. In the place of 1 minus sine squared theta, I have cos squared theta. Everything divided by cosine squared of theta. When I work out with this, you can see that each term we can call it divide through by cos theta. If I divide here by cos theta, I get 1 plus. If I divide cos theta sin theta by cos theta, I'm going to get sin theta. If I divide cosine squared theta by cos theta, I'm going to get cosine of theta. And down here, when I divide cos squared theta by cos theta, I get cosine of theta. What I've done, I call it dividing through by cosine of theta. And what I have here, 1 plus sine theta plus cos theta over cos theta, is exactly what we have on the right hand side of our given identity. I sign out. Peace. And now this question is asking us to eliminate the value of theta from the pair of equations. When you look at these equations, they look similar. The only thing is that one is plus and one is minus. So we can utilize a difference of two squares identity. We can have x, y equaling to, now we can open the brackets, we expand. When we expand this, we shall have, that. And what can we say about cosec squared theta minus cot squared theta? That one is equal to 1. It comes from the fact that cos squared theta plus sine squared theta equal to 1. When I divide through by sine squared theta, cos squared theta divided by sine squared theta, I get cot squared. Sine squared theta divided by sine squared theta, I get 1. 1 divided by sine squared theta, I get cosec squared theta. So we have that if I take cot squared theta to that side and we turn the equation around, we shall have cosec squared theta minus cot squared theta equal to 1. This one means that xy is equal to 1. That is the version of those two equations after eliminating the value of theta. For this one, we are going to employ the help of a right-angled triangle. They have given us that y is equal to tan theta. We can write this that tan theta is equal to y, and that y is the same as y over 1. And we know that tangent of theta is opposite divided by adjacent. So we can have this as this one is we look at this right angle triangle with respect to angle theta. This one is the opposite. So we have a y there and we have 1 there, which is the adjacent, and the hypotenuse by Pythagoras theorem shall have it as y squared plus 1. And from there, it means that the sine of theta is given by opposite, which is y over hypotenuse, which is square root of y squared plus 1. And then the cosine of theta, which is given by adjacent over hypotenuse, will be 1 divided by square root of y squared plus 1. We can now substitute that in that equation, putting where there is sine theta, we apply this expression, and where there is cos theta, we put that. So x is equal to y over square root of y squared plus 1 plus the cosine of theta, that is 1 over square root of y squared plus 1. You realize that the denominator is the same, so we can have that x is equal to y plus 1 divided by square root of y squared plus 1. We shall cross multiply, assuming that is over 1. X times y squared plus 1 is equal to y plus 1. And now from there, we are going to square both sides. And when we square both sides, the root of this one will go away. And we have x squared into y squared plus 1 equaling to y plus 1, everything squared. That is the solution. We have eliminated theta from these two equations. I sign out. Peace. Here we are required to solve this equation for the values of theta from 0 to 360. What we are going to do, we realize that we have a cosine and we have a sine, and the sine is squared. So we can apply the Pythagoras theorem. Cosine squared, we can apply this. That identity, you can learn it. It is an important one. So from here it means that the sine squared is 1 minus cos squared of theta. We are going to substitute that in this. So 3 minus 3 times cosine of theta is equal to 2 into 1 minus cos squared, and we shall have 3 equal to 3 cos theta equal to, let us open the brackets, this is minus 2 cos squared theta. Let's take this one that side. We get all the terms on the right and we pull them to the left. So we have 2 cos squared theta minus 3 cosine of theta. These 2, these 3, and these 2 shall have plus 1 equaling to 0. We shall select x equal to cos theta. This will imply that 2x squared minus 3x plus 1 equal to 0. We shall now solve for x and we substitute it back. This one can be factorized as 2x, and this one is okay, 2x squared minus 2x minus x plus 1 equal to 0. So that we have 2x into x minus 1 minus 1 into x minus 1 equal to 0. This one is now getting us 2x, pulling out to x minus 1, remaining with 2x minus 1 into x minus 1 equal to 0, such that now we have that either 2x minus 1 equal to 0, implying that x equal to 1 over 2, or x minus 1 equal to 0, implying that x is equal to 1. So for x equal to a half, it implies that we can start now. Since x equal to a half, we now have that when x is a half, then cosine of theta is equal to 1 over 2, implying that theta is equal to the arc cos of 1 over 2, and this theta will be equal to 60 degrees. Cosine of theta is positive here, and so we shall get two values, one in the first quadrant, another in the fourth quadrant. The angle in the fourth quadrant can be got by getting 360 minus the angle you got, which is the acute angle. So we shall get 360 minus 60, getting us 300. So the other angle here, the other angle is 300. Then we have the other value of x is here, which is 1. So cos of x, cosine of theta equal to 1, implying that theta is equal to cos inverse of 1, and theta is equal to, the cos inverse of 1 is 0, and that one can also be 360. So if you write the answers, the values of theta between 0 and 360 degrees inclusive, that satisfies the given equation are, we have 0, I'm going to write them in order. We have 60 degrees, we have 300 degrees, and then 360 degrees. This one is another example. Actually, I'm having only these two examples, but you can get this method. You can see how I'm handling it, and you can be able to solve very many other problems. Here, when you look at this, we have cot and cosec. The relationship between cot and cosec is that 1 plus cot squared is equal to cosec squared. So where I have cot, I can substitute there cosec squared minus 1. So we have here that 2 into, this one is cosec squared theta minus 1. That one is now in the place of cot squared, plus 8. We get, this one is 7 cosec theta. Open the brackets. 2 cosec squared theta minus 2 plus 8 is equal to 7 cosec theta. We shall write it as a quadratic in cosec. 2 cosec squared theta minus 7. This one is cosec theta. We take all the terms to the left. This one is plus 6. This negative 2 and that 8 will get us a positive 6. Everything is equal to 0. We can either say that let cosec equal to maybe y or x, but we are going to, I am deciding to take it as cosec. So find two numbers whose sum is negative 7 and whose product is 12. That is these 2 times that 6, and those numbers can be seen to be minus 4, minus 3. I get these numbers and distribute them in the place of the 7 cosec. So I have 2 cosec, this is cosec squared theta, minus 4 cosec theta, minus 3 cosec theta, plus 6 equal to 0. Now factorize out 2 cosec theta. It is here and there, and you remain with the cosec theta minus 2. Then minus 3 into again cosec theta minus 2 equal to 0. From here we can see that when we pull out cosec, we shall pull out cosec theta minus 2, and around here remaining with the 2 cosec theta. Then here we remain with 3. Everything is equal to 0. So we have that when we look at this, we have 2 brackets, and if that thing will give us a 0, it means that either cosec theta minus 2 is equal to 0, implying that cosec theta equal to 2. This implies that sine of theta is equal to 1 over 2. Cosec theta is the reciprocal of sine. So the reciprocal of sine is cosec theta. And if that is the case, we have that theta is equal to cosine of 1 over 2, getting us theta, which is the first value is the acute value is 30 degrees, and the other angle is in the second quadrant. That is where sine is positive, so that one is 150 degrees. So we have either that, or the other one is that 2 cosec theta is equal to 3. From here, 2 cosec theta minus 3 is also equal to 0, such that this is correct, implying that cosec theta is equal to 3 over 2. Therefore, this one is sine theta equal to 2 over 3. And from there, you can see that theta is equal to cosine of 2 over 3. Your calculator will give you that the first angle is 41.8, and the angle in the second quadrant is 180 minus this first angle you get. So it is going to be 138.2 degrees. These angles satisfy that equation. If I want to write them in order, I have that theta is equal to 30 degrees. The other one is 41.8 degrees. I have another one as 138.2 degrees, and the last one is 150 degrees. Those are the solutions to that particular equation. If you have any problem, my inbox is open. You can send your query. I shall make a video on it. This question, the thing I want you to look at, take a look at the constraints. They want us to find the values of theta between negative 180 and 180 degrees. How can we go about that? We are going to say that let sine of theta be equal to m, and we have that 2m squared minus m minus 1 equal to 0. Putting where there is sine theta, we put there m. This one is going to factorize to 2m plus 1 into m minus 1 equal to 0. And this means that 2m plus 1 equal to 0, implying that m is equal to negative 1 over 2, or we have that m minus 1 equal to 0, implying that m is equal to 1. And now, for m equal to 1, we have that sine of theta equal to 1, implying that theta is equal to the cosine of 1, which is equal to 90 degrees. We have another one. For m equal to negative 1 over 2, we have that sine of theta equal to negative 1 over 2. And now, if sine of theta is equal to negative 1 over 2, here we don't just say that theta is equal to a cosine of negative 1/2. No. This time, we have to find the cosine of 1 over 2. Not putting the negative, it is a cosine of 1 over 2, and that one is 30 degrees. Now, the angle which is 30 degrees, this is 30 degrees, is the angle of inclination to the horizontal. The sine of theta is negative. So that one means that we are going to work in the third quadrant and the fourth quadrant. I have labeled where we have the 30, and I'm going to show you how we are supposed to get the angles which are required for the given problem. Now this one is the angle 30 we got. But now the angles are measured from the positive x direction up to the direction in question. So that angle, the angle which can satisfy the value of theta, can be got by that angle there. I want to tell you that this angle is 210 degrees, and that angle 210 does not lie within the given range. So what we are going to do, we shall not use that, but we are going to measure that angle from this direction, and that angle is 150. But remember, angles in this direction are positive, while angles in this direction are negative. So you can either take the positive angle from the positive x direction anti-clockwise, or you can get the angle from the positive x direction clockwise, and you have it as negative. So this angle is 150, and we are going to take it to be negative because it is being measured from the x direction, from the positive x direction in the clockwise sense. We now have that the value of theta itself is negative 150 degrees from this one here. Instead of 210, which is outside the range, we are preferring to write negative 150. And actually, if you try to get the sine of 210, you are going to get the same answer when you get the sine of negative 150. Now, the other one, the angle in the fourth quadrant, that is the way I've indicated it with the first angle we got. This is 30 here. The arc sine of half we got is the one is where I'm getting that 30. So inclination to the horizontal, 30 degrees. But how do we get the angle? I can get that angle like this. And if I'm to get that angle, it's going to be 330 degrees. And it is far beyond the range. So what I'm going to do, instead of taking the positive angle in the clockwise direction, I am going to take the negative angle, this one, in the negative direction. So that angle is negative 30 degrees. So that means that theta, we had 210, which we can write as negative 150, and now we are having 330 degrees, which we can write as negative 30 degrees. So from here, the values of theta we have the 90, 150 negative, and then negative 30 degrees. This is part B now. We have tan theta is equal to 4 cot theta plus 3. We know that cot theta is the reciprocal of tan theta. That means that we have tangent of theta equaling to 4 divided by tangent of theta plus 3. We shall multiply through by tan theta, and we have tan theta squared equaling to 4 plus 3 tan theta. We shall write this as a proper quadratic equation in tan squared theta minus 3 tan theta minus 4 equal to 0. We shall let tan theta be equal to m, so that we have that now m squared minus 3m minus 4 is equal to 0. This one factorizes to m minus 4 m plus 1. Now this means that either m minus 4 equal to 0, implying that m is equal to 4, or we also have that m plus 1 equal to 0, implying that m is equal to negative 1. Since tan theta is equal to m, we have that the tangent of theta is equal to 4, and the arctan of 4, this one gets us 76 degrees, and the tangent of theta is positive in the first quadrant and the third quadrant, and the angle in the third quadrant is supposed to be 180 plus 76, which is supposed to get us 256 degrees. But now 256 is outside the range, so we are going to take the negative, the other part, the negative angle. We have this angle is 76, this one here is 76, and the 256 is that one, and that is from that side we have positive. So since this angle from that side is bigger than the ones we have in the range, we are going to move in this direction, and we have a negative angle. From the positive x direction, clockwise, we have negative, and that angle is 180 minus 76, and that one is 104, but negative now, negative 104, negative 104 degrees. Then the other one is we have tangent of theta equal to negative 1, and the tan inverse of 1 is 45 degrees. And remember, tangent is negative in the second quadrant and the fourth quadrant. The angle in the second quadrant is got by getting 180 minus the acute angle you get. So this one, if I subtract that, I get 135 degrees. So we have that the first value of theta is 135 degrees. We have another value in the fourth quadrant, and how do we get that value? The inclination to the horizontal is 45 degrees, and the angle is supposed to be this one. If I work out that angle, I'm going to get 315 degrees, and that angle is outside the range. So what we are going to do, instead of measuring it like that, and we have a positive one, we shall measure it like this, and we have a negative angle. And so this direction is 315, but also it is negative 45 degrees. So those are the answers, those are the values of theta within the given constraints. This point is O, and we have OP in the first quadrant. There is another OP in the second quadrant, and another OP in the third quadrant, and even in the fourth quadrant. I want us to consider this 30 degrees, this one also 30 degrees. The same applies to this 30 degrees and this one. So in all the quadrants, OP is inclined at an angle of 30 degrees to the x-axis. It can be the negative x axis or the positive x-axis. It doesn't matter which side. What matters here is the inclination to the horizontal axis. Now we need to know this. The sine of 30 degrees is 0.5. This angle for this OP, which is in the first quadrant. Remember, all angles are measured in this direction like this. All angles are measured from the positive x direction, and if they are measured anti-clockwise, they are negative, they are positive. And when they are measured, actually it is that term, when they are measured in the anti-clockwise direction, they are positive, while those which are measured in the clockwise direction are negative. So this angle from the horizontal, from the positive horizontal to line OP, that angle is 30. It is positive 30. That angle which is positive 30, if I measure it from the negative, I shall go like that side like that, and I shall have 30 degrees is the same as negative 330 degrees. That is, if I pass from here, from the positive side, I have 30. From the negative, I rotate this side like this, I have negative 330. I have labeled some angles here. This one is orange. I have an orange angle. I have a purple angle from here to that point. That angle is 150. Its sine is 0.5. There is the green angle. It is 210 degrees. Its sine is negative 0.5. We have the blue angle. It is 330, and its sine is negative 0.5. Let's try to look at the cosine of these angles. The cosine of 30 degrees is 0.866. If I write that to 3 decimal places, the cosine of 150 is negative 0.866. The cosine of 210 degrees is negative 0.866, and the cosine of 330 degrees is 0.866. The concept I want us to derive here is that all angles which bear the same inclination to the positive x-axis or negative x-axis, they have related trigonometric ratios. The magnitudes of the trigonometric ratios of those angles are the same. Their sines are determined by the quadrant where the angle is found. For example, the sine of 30 is positive because 30 is in the first quadrant. The sine of 150 is 0.5. It is positive because sine theta is positive in the second quadrant. The same applies to that of the sine of the third quadrant and that of the fourth quadrant. So all angles which bear the same inclination to the horizontal have related ratios. Now, if I have some other angle other than 30, it is the same thing. Instead of 30, if we had 45, we would be having that is the acute angle. I have even this one as a 45, then 45. Then we shall be having the related angles will be 45 degrees 135 degrees in the third quadrant, so it is 225 degrees, and then this one is 315. All of those angles, if you are to get the cosine of all of these, it bears some 0.707. However, for that one of the second and the third, it will be negative, because cosine is negative in the second and the third quadrant. If I got the tangents of these angles, the tangent of 45, that one will be 1, tangent of that is 1, tangent of 45 is 1, tangent of 135 is negative 1, tangent of 225 is 1, and the tangent of 315 is negative 1, because the tangent is positive only in the third quadrant and the first quadrant. Actually, in the first quadrant, all of them are positive. I want to bring out a concept of negative angles. What does an angle of negative 70 mean? Negative 70 degrees. Negative 70 degrees means that you are moving from the positive x-axis and you are moving 70 degrees clockwise. Let us consider when this diagram is like they have labeled these 50s. The angle in the first quadrant, if that angle is 50, if you have the inclination 50 to the horizontal, 50, 50, 50, 50, then the angle in the first quadrant is either 50 degrees, or I can have negative 310 degrees, because if I traverse the quadrant circle in the anti-clockwise sense, I shall be having from here upwards, that is positive 50. And when I move in the other direction, in the clockwise direction, that direction OP in the first quadrant, this is the angle. Then we can have the angle in the second quadrant is 180 minus 50, which is equal to 130 degrees. And if I move in the negative sense, the negative from the positive x direction, moving in this direction, I shall be having 180 plus 50. I shall have an angle of 230 degrees, and that one will be negative because I have moved in this direction. It is going to be negative of 230. If you try to get the sign of this, actually for these ones they are the same. Sine of this is equal to sine of this. Cos of that is cosine of that. Tangent, the tangents are the same. The tangents of these two, 50 and negative 310, they are the same. Now, what about the angle in the fourth quadrant? This one was the first quadrant, second quadrant. Now the angle in the third quadrant. That is if we got that the acute angle, and that's the angle we can get by getting the aka tan, aka cos, aka sine. The first that angle you get there. So that's the angle you distribute in the quadrants and you get the various angles. The green angle is 180 plus 50, and that one is 230 degrees. And if I traverse clockwise, I have that angle as negative 130 degrees. The angle in the fourth quadrant, it is either the blue angle, this one, the blue angle, which is equal to 310 degrees, or I can have it clockwise and I have negative 50 degrees. So the negative angles are got by having the circle moved from the positive x-axis clockwise. You measure those angles clockwise from positive x-axis. Positive angles are measured from the positive x-axis anti-clockwise. So for every positive angle, there is a corresponding negative angle, as you can see here. For every positive angle, there is a corresponding negative angle. And if, for example, a question was asking you to get the values of theta, solve a certain equation, they give you sin theta is equal to maybe 0.5, something like that, and they wanted to find the value of theta. Of course, we have a number of values, and then they tell you that maybe theta lies between, they can talk about negative 180 degrees and 180 degrees. So that's what they are saying. You know that theta here will be the first quadrant angle is 30. We have an angle of 30 in the first quadrant, and we have an angle of 150 in the second quadrant. That one doesn't change anything. But supposing they told you that cosine of theta is equal to 0.5, what will you do? Cosine of theta is 0.5, and we know that theta is equal to cos inverse of 0.5, which is going to be 60 degrees. And the cosine of theta is positive in the first and the fourth quadrant. The angle in the fourth quadrant, which is corresponding to an inclination of 60 there, is 300, and the 300 degrees is beyond that. So instead of having 300, you just write an angle of 60 degrees. For an angle of 300 in the fourth quadrant, by traversing this quadrant circle anti-clockwise, there is a certain other angle which is negative, which is now this time negative 60, which is obtained by traversing it clockwise. So there is always that pair. We shall start from ratios of 30 and those of 60. This one is an equilateral triangle. An equilateral triangle has all sides and angles equal. So this one is 60, 60, and 60. Now we have bisected this angle and bisecting this side, and that makes this angle 30 and that one 30, because we have bisected that. If this one, if we have that every side is 2 units, then this one is 1. We shall have a 1 here and a 1 for that. And now we have that the sine, if we are to get the sine of 30 degrees, this one, that angle there, with reference to that angle, the opposite is here and the hypotenuse is there. So we know that sine of 30 will be equal to opposite divided by hypotenuse, and the opposite is 1, the hypotenuse is 2. The cosine of 30 degrees is adjacent, which is root 3, then divided by 2, which is the hypotenuse. The tangent of 30 degrees, tangent of that same angle, is the opposite, which is 1, divided by adjacent, which is root 3. We can come to the 60s now, the ratios of 60, that angle. So we have that the sine of 60 degrees is equal to root 3 divided by 2. The opposite is root 3, hypotenuse is 2. The cosine of 60 degrees is equal to adjacent, which is 1, divided by hypotenuse, which is 2. The tangent of 60 degrees is equal to root 3, that is the opposite, divided by 1, the adjacent. So the tangent of 60 is root 3. Well, for the ratios of 45 degrees, we use the right angled isosceles triangle, where the two equal sides having a length of 1 unit. By Pythagoras theorem, this one is square root of 2, the hypotenuse. Now the sine of 45 degrees, I consider this angle here, it is equal to opposite. The opposite is 1 and the hypotenuse is root 2. The cosine of 45 degrees is equal to adjacent, that is 1 divided by hypotenuse, which is root 2. The tangent of 45 degrees is equal to opposite, which is 1 divided by adjacent, which is 1. So the tangent of 45 is 1. I sign out. Peace. This one is the compound angle formula. You have A, this A and B, they are angles. So what you can use about the sign of angle A plus angle B? This one can be expanded as the sine of A times the cosine of B, add it to the cosine of A times the sine of B. Sine of A minus B is equal to sine of A cosine of B minus cosine of A sine of B. When it comes to cosine of A plus B, you have cosine of A cosine of B, and when this one is plus, you have a minus here. This one is sine of A times sine of B. Cosine of A minus B is equal to cosine of A times cosine of B, and the symbol there is a plus. Sine of A times sine of B. Tangent of A plus B, you get the tangent of A, you add on the tangent of B, and you divide by the this one is divided by 1 minus tangent of A times tangent of B. When it comes to tangent of A minus B, you have the tangent of A minus the tangent of B divided by 1 plus the tangent of A times the tangent of B. This one is an example which requires us to use the compound angle formula. They gave us that if sine of A is equal to 3 over 5 and sine B is equal to 5 over 13, where A and B are acute angles, find the values of sine of A plus B, cos of A plus B, cot of A plus B. We know that the sine of A plus B is equal to sine of A cos B plus cos A sine B. And from what they have given us, they didn't give us any cosine of B. We don't have cos B, we don't have cos A. But when we know the sine of A, as they have given us here, we have the sine of B, we can get the cosine of A, and even here we can get the cosine of B. We are going to use, we can either use the Pythagoras theorem, or we can say that cos squared A plus sine squared A is equal to 1, or we can get that cos squared A is equal to 1 minus sine squared A. And when we have that, this is 1 minus the sine squared of A, that one is 3 over 5 squared, and this one shall have that cosine of A will be got as 4 over 5. Now with this, what we're going to do, we're not going to use this, but it is okay. But we can have, we are going to say that sine of A is opposite. So we are going to put here that one opposite, which is 3, divided by hypotenuse for a right angle triangle. So if we have this right angle triangle, the adjacent is going to be 4 by Pythagoras theorem. This one squared minus 3 squared under root. Then for sine of B, we have this angle as B. This one is angle B. And if that is angle B, we now have the opposite as 5. Sine B is opposite over hypotenuse. So the hypotenuse here, it is 13. And now the adjacent for this particular triangle is going to be 12. And so the cosine of A is equal to adjacent, which is 4, divided by hypotenuse, which is 5. While here the cosine of B is adjacent, which is 12, divided by hypotenuse, which is equal to 13. And now we can get these values and substitute them here. So we have sine A, which is equal to 3 over 5 multiplied by cosine of B, 12 over 13, plus cosine of A, 4 over 5 times sine of B, which is 5 over 13. This one is going to get us 36 divided by 65 plus 20 divided by 65, which is equal to 56 divided by 65. That is what we have for sine of A plus sine of A plus B. Then for cosine, we have cosine of A, but B is cos of A plus B. We know that this one is supposed to be cos A, cos B minus sine A, sine B. Cosine of A is 4 over 5. Cosine of B is 12 over 13 minus sine of A is 3 over 5. Sine of B is 5 over 13. This one will get us 48 over 65 minus 15 over 65, which is equal to 33 over 65. But C is cot of A plus B. We need to know that the cot of A plus B is the same as the reciprocal of the tangent of A plus B. And the reciprocal from the compound angle formula of tangent, this one becomes the reciprocal. It is 1 minus tan A tan B divided by tan of A plus tan of B, and 1 minus the tangent of A from this thing, from here, opposite over adjacent. That one is 3 over 4 multiplied by the tangent of B. The opposite was 5, is 5. The adjacent is 12. We are going to divide this by tangent of A, 3 over 4 plus 5 over 12. And this will get us 1 minus whatever is up there is 15 over 48, and we are going to divide this by, that one is going to get us, it is 14 divided by 12. And if I work out the upper thing, I'm going to get 33 over 48 divided by, same as multiplying by the, which is the same as multiplying by the reciprocal, 12 over 14. This one will get us 33 divided by 56. That one is the cotangent of A plus B. Someone may ask, how do we find the value of the cosine of 75, and we have thirds remaining in our answer? Some time back we talked about the compound angle formula, and we are going to use it here. So we know that 75 can be written as 45 plus 30. So we are going to have this one as the cosine of 45 degrees plus 30 degrees. And then by the compound angle formula, we shall have the cosine of 45 degrees times the cosine of 30 degrees minus sine of 45 degrees times the sine of 30 degrees. The cosine of 45 degrees is 1 over root 2. That video is on this page that can tell you how to get the cosine of 45 using Pythagoras theorem. The cosine of 30 is root 3 over 2. The sine of 45 is also 1 over root 2, and the sine of 30 is 1 over 2. So we shall have, there is a 2 root 2 down everywhere, so we have 1 over 2 root 2. Up here we remain with the root 3 minus 1. We also have this, the sine of 15 degrees. How can we find the value of sine of 15? We shall still write this one as sine of 45 degrees minus 30 degrees. This one is the same as sine of 45 degrees times the cos of 30 degrees minus sine of 30 degrees times the cosine of 45 degrees. Now the sine of 45 is 1 over root 2. Cosine of 30 is root 3 over 2 minus sine of 30 is 1 over 2. Cos of 45 is 1 over root 2. And still we have 1 over 2 root 2 into root 3 minus 1. Well, you remember we had the compound angle formula. Now I want to use those formula to get the double angle formula. If you have that A is equal to B, then you are going to have that the sine of 2A is equal to sine A times the cosine of A, because B is the same as A, plus sine of A times cosine of A. And this one is going to get us 2 sine A cos A. The same applies to this. If you have that A is equal to B, then we are going to have that cosine of 2A is equal to cos squared A minus sin squared A. Cos squared A plus if I use this and I make a sin squared A the subject of the formula, sin squared A is equal to 1 minus cos squared A. If I substitute this in the place of sin squared, I'm going to have that cosine of 2A is equal to 2 cos squared A minus 1. And that one can lead us further to this result, that when I have cosine squared of A, from here I can make a cosine squared the subject of the formula. It is going to be equal to a half into 1 plus cosine of 2A. Instead of making sin squared the subject of the formula, if I make a cos squared the subject of this one here, I'm going to have that cosine of 2A. I'm substituting here, putting there 1 minus sin squared from this. I shall have that cosine of 2A is going to be equal to 1 minus 2 sin squared of A. And if I make sin squared the subject of the formula, I shall have that sin squared A is going to be equal to a half into 1 minus cosine of 2A. And if A is equal to B in the tan formula, I have that tangent of 2A is equal to 2 times tangent of A divided by 1 minus tan squared A.